In this video, I'm going to show you how to solve multiple right triangles. So we want to find the missing lengths x and y in this triangle below, which is composed of two triangles, a left triangle here and a right triangle here, and we'll round our answers to one decimal place. Okay, so how do we take this diagram and pull out some equations that we can use to solve for x and y? Well, what triangle should we start with? We're given angle measure, so that's a good sign that we're going to be using trig ratios. But what triangle should we look at first? This one with a 40-degree angle or this one with a 20-degree angle? Well, the key to deciding what triangle to start with is to look for the one that you know more information about. So on this left triangle, we only have an angle of 40 degrees, or on the right triangle, we have an angle of 20 degrees and a side length of 5. So that's a good indication that we'll be able to figure out what x is using this right triangle. Because that has more information. And then once we know what x is, then we can use that to solve for y. Okay, so taking this right triangle, let's set up a trig ratio for 20 degrees that relates x and 5. So remember, for trig ratios, the way to remember that is SOHCAHTOA. Sine is opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. And looking at 20 degrees, x is opposite and 5 is adjacent, so that indicates that we're going to be looking for tangent. So tangent of 20 degrees in this triangle, that's going to be equal to opposite x over adjacent 5. And there we go, an equation that we can use to solve for x. So let's go ahead and solve for x, multiply both sides by 5. 5 tangent of 20 degrees is equal to x, and then we'll just punch that into our calculator. Make sure you're in degree mode for the 20 degrees, and we get that x is roughly equal to 1.8199. And I know it says to round your answers to one decimal place, but we're going to be using x to solve for y, so we don't want to introduce any round off error. We want to be very precise with x so that our answer for y isn't incorrect due to any imprecision in x. Okay, so we've got x, now it's time to solve for y. To make it easier for us to visualize what's going on, let's go ahead and write that value in the diagram, 1.8199 for x. Now when we're solving for y, we're looking at this 40-degree angle. And we want to relate two sides with a trig ratio. We know this side, which is x, that's just 1.8199, and we're looking for y, so we want to choose the trig ratio that involves opposite and hypotenuse. So that's going to be sine. So opposite over hypotenuse, and so let's write that down here. Sine of 40 degrees is opposite, which is x, which is just 1.8199, over hypotenuse, which is y. That's what we want to solve for. So let's go ahead and solve for y. Multiply both sides by y, we get y sine of 40 degrees is equal to 1.8199, and then divide both sides by sine 40 degrees, you get y is equal to 1.8199 over sine of 40 degrees. We punch that in our calculator, make sure you're in degrees mode, and we get a result of y is approximately 2.8 rounded to one decimal place. Okay, so now let's gather our answers. We've got y is approximately 2.8 and x, let's go ahead and round that off to one decimal place now. We've used the 4 decimal places to solve for y, but now we want just one decimal place, so x is approximately equal to 1.8. And there we go, we're done. There are our values for x and y rounded to one decimal place. Alright, here's another example. We want to find the missing length a and the missing angle theta in this triangle below, and we'll round our answers to one decimal place again. Okay, so this time we're missing a side and an angle, but the general principle is still the same. We want to start off solving in the triangle which we know more information about. So in the right triangle, all we know is the side 6. And then in the left triangle, we know the side 7 as well as this angle of 55 degrees. So we've got two pieces of information in this left triangle, so why don't we use that to set up an equation to solve for a. Okay, so we want something that involves 7 and 55 degrees and a. Let's set up a trig ratio for 55 degrees. Again, SOHCAHTOA. And we're looking for a is adjacent to 55 degrees, 7 is hypotenuse, adjacent hypotenuse, that's cosine. So let's use cosine. Cosine of 55 degrees equals adjacent over hypotenuse. Adjacent is just a, and hypotenuse is 7. So solve for a by multiplying both sides by 7. 7 cosine of 55 degrees is equal to A. Punch that in your calculator, make sure you're in degree mode, and you should get a result of roughly 4.0150. And we're rounding to 4 decimal places again because we're going to be using A to figure out what theta is, and we don't want to introduce any significant round-off error that might give us a wrong result for theta. So A is approximately 4.0150, and now it's time to figure out what theta is using that result. So let's write this in our diagram. A is approximately 4.0150, just to make it clear what we know about this right triangle. And now we're looking for theta. So what relates these two pieces of information, 4.0150 and 6? Well, these are just the opposite and hypotenuse relative to theta. So we're going to be looking for a trig ratio sine. Sine is opposite over hypotenuse. So let's take sine theta. That's going to be equal to opposite A 4.0150 over hypotenuse, which is just 6. Okay, so now we want to solve for theta. And the way we can do that, we can cancel out this sign by applying the inverse sign. So theta is just inverse sine of that right-hand side argument, 4.0150 over 6. And we'll go ahead and punch that into the calculator. We get theta is approximately, to 1 decimal place, 42.0 degrees. Okay, so let's go ahead and finish this off. We'll round A to 1 decimal place now. That's just A is approximately 4.0, and there we go. We've got our two variables rounded to 1 decimal place. There's our solution. Here's a final example. Now we want to find the area of this triangle below. And we want to round our answer to 1 decimal place again. We've got some information in our diagram here, but let's take a step back and just think about area. What's the formula for area of a triangle? Area of a triangle is just a half times base times height. Okay, so that seems simple enough. So what's the base of this triangle? Oh, wait, we don't know the base. So the base has some variable in it, m. It's m plus 3. Same with the height. The height is k. We don't know what k is yet either. So in order to figure out what the base and the height are to put in our area formula, we're going to have to figure out what are m and k. Alright, so let's forget about this area formula for a moment while we solve for m and k. And how should we do this? Well, let's apply the same process that we did before. Look for the triangle that we know the most information about. That's this triangle on the right. We've got 2 pieces of information, whereas on the left we only have 1 piece of information. So what can we do with the triangle on the right? We don't have any angle, so it doesn't look like trig functions are going to be helpful. So how can we figure out if we've got a right triangle with 2 sides and want to find a 3rd side, what do we do? Well, we can use the Pythagorean Theorem. That relates all of the sides of a right triangle. So Pythagorean Theorem, that is just k squared plus 3 squared is equal to 5 squared. Leg squared plus leg squared equals hypotenuse squared. So k squared plus 9 equals 25, so k squared is equal to 16, and then taking the square root of both sides, k is just equal to 4. And we just care about the positive square root here because k is a physical quantity. Alright, so let's write that in on our diagram. K equals 4, and now it's time to solve for m. So now that we know what k is, we know the opposite side here relative to 25 degrees, and we want to find the adjacent side. What relates opposite to adjacent? Well, let's write our SOHCAHTOA. SOHCAHTOA, opposite and adjacent, hey, that's tangent. So tangent of 25 degrees is equal to opposite, which is k, which is 4, over adjacent, which is m. And we can use that to solve for m. Let's multiply both sides by m. M tangent of 25 degrees equals 4, and then divide both sides by tangent of 25 degrees and just get 4 over tangent 25 degrees. That's what m is equal to. So let's go ahead and punch that into our calculator, and we'll get a result of approximately 8.5780. Again, rounding to 4 decimal places so that when we plug that into our area formula, that we can get that area formula correct to 1 decimal place. We don't want to introduce any round off error, so we're being very precise with m. Okay, so now it's time to go ahead and plug this into our area formula. Let's just go ahead and write this in our diagram also. So m is 8.5780, and now turn back to our area formula. So area is a half times base. Well, base is just m plus 3, so 8.5780 plus 3, let's write that down. That's just 11.5780. And then the height is now just k, so that's 4. Okay, so now we're in a good position to just go ahead and compute this, and we get a result. Area is approximately 23.2 when we round it to 1 decimal place. So there's our result. Area is approximately 23.2 rounded to 1 decimal place. So now we know how to solve for missing parts of triangles when there are two triangles which share a common side. And in the future, we'll see how to apply what we've learned to word problems as well.